Welcome to Ask and Learn.
Okay, well, in this problem we have to explain what happens to the gas temperature and pressure of an ideal Otto cycle when we double the compression ratio. Okay, so let's do a really simplified diagram, PV diagram for an Otto cycle here, just to see the idea. So the Otto cycle, we have two uh, two transformations with constant volume, and we have two isentropic transformations. So this is the first isentropic, this is the second isentropic, okay? And isentropic means that we do not exchange heat with the surroundings. Therefore, the heat only enters here and leaves here. And this is 1, 2, 3, and 4. Okay, we want to know what will happen with the temperature and pressure when we double the compression ratio. So, first of all, let's remember that if we look to the transformation 1, 2, which is an isentropic transformation, what we have is that the temperature is going to be uh, T2 equals T1, V1, V2, K minus 1. So this is the standard isentropic transformation in an equation, okay? And we must remember that V1 divided by V2 is basically the compression ratio. So this is T1 that multiplies R, K minus 1. Okay, so this is T2, but the maximum pressure of the Otto cycle happens in the temperature 3. We always must remember this. Therefore, the maximum pressure in the Otto cycle is the temperature 3, which is separated by uh, a transformation with constant volume between the points 2 and the point 3. Therefore, T3 is just the input heat divided by Cv plus T2, and we already know what is the temperature 2. Therefore, the maximum temperature, or the temperature 3 in an Otto cycle, represented by the compression ratio, is just going to be the input heat divided by Cv plus T1 R K minus 1. Okay? Well, so that's the equation for the temperature. Now we have to look to the pressure. And well, the maximum pressure also occurs in the pressure 3. So the maximum pressure is the pressure 3, and is separated by an ideal gas law. So this is PV equals RT. So this is RT3 divided by the volume 3. Okay? Well, we can use uh, the relation between the compression ratio and say that compression ratio R is just V1 divided by V3. Therefore, what we have here is that R divided by V1 multiplied by the compression ratio that multiplies the temperature 3. And we already know what is the temperature 3. Therefore, the answer for the pressure, P3, is going to be uh, capital R plus R divided by V1 that multiplies the input heat divided by Cv plus T1 R K minus 1. And this is the equation for the pressure, this is the equation for the temperature, and that's the answer to this problem. Okay? Thanks for watching.